Hello students, welcome back to the maths class. In today's class, let us derive the equation of plane. So here, equation of plane can be derived if any one of the following three conditions we know. That is, first is if we know the normal, that is the perpendicular to the plane, and also what is the distance of this perpendicular from origin to the plane. If we know this, then we are able to find what is the equation of the plane. Or else, if we know if the equation of a line is passing through a point and perpendicular to the given direction, then also we know we will be able to derive the equation of that plane. Or else, if we can derive if it passes through three non-collinear points. So out of these three conditions, if any one of the condition is known, then we can find what is the equation of that plane. We are going to derive all the three under all the three conditions. In today's class, let us derive the equation of a plane in normal form. That is, we know what is the perpendicular to the plane and also what is the distance of this perpendicular from origin to the plane. Under this condition, what is the equation of the plane? Let us see. So this is important. Again, this will be asked for 5 marks. Okay, in your 5 marks question. So out of there are 7 to 8 derivations. Out of this is also one of them, which is important. So equation of a plane in normal form. So let us consider a plane here. So I am considering a plane, okay, whose distance from the origin is d. So this is d. So let us write what we have considered. Consider a plane whose perpendicular distance from the origin is d. Okay, consider a plane whose perpendicular distance from the origin is d. And we know that this distance should be always not equal to 0. This is the first step. So we have considered a plane whose perpendicular distance from the origin is d. Next, if ON is the normal vector, if ON, vector ON is the normal vector from the origin to the plane, then n cap is the unit normal vector along ON, along the vector ON. That is, if ON is a vector, what kind of vector? Normal vector, means that is perpendicular. If ON is the normal vector from the origin to the plane, then n cap is the unit normal vector along ON. That is, you have in this direction you have a vector n cap. Therefore, from this I can write vector ON is equal to, vector is magnitude into direction. Here the magnitude is nothing but d, and it is in the direction. Along which direction? It is along with the direction of n cap. Why? Because n cap is the unit normal vector along ON. It is in the direction of the vector ON. Okay. Then let us consider any point P on the plane. So let P be any point on the plane such that vector np dot vector on is equal to 0, or we can write such that vector np is perpendicular to vector on. Okay, if I consider a point P, how is this point we have considered? Is that the vector NP is perpendicular to vector ON. We have considered a point P in such a way that vector NP is perpendicular to vector ON, so that from this I can write vector NP dot vector ON is equal to 0. Why? Because if the two vectors are perpendicular and the dot product between these two vectors will be equal to 0. We have already studied under the observations of the dot product, that is, if vector A dot vector B is equal to 0, this implies that these two vectors are perpendicular, or vector NP and vector ON are perpendicular, then we can say that the dot product between these two vectors is 0. Okay, so with this, so we know what is vector NP and vector ON. Here, I consider let R be the position vector of the point P. Okay, let R be the position vector of the point P. Okay, so here now you can see the triangle. Let us apply the triangular law of vector addition. So from this I can write, then we have, okay, vector ON. I am using the triangular law of vector addition. Vector ON plus vector NP will be equal to vector OP. Therefore, I can write vector NP as vector OP minus vector ON. So this is equal to, what is vector OP here? Vector OP is nothing but, okay, we will write vector OP as vector R, because vector R is the position vector of the point R. Therefore, vector OP is nothing but vector R minus vector ON. We have already seen what vector ON is, which is D into N cap. Now let us substitute this NP in this equation. Therefore, vector NP dot vector ON, which is equal to 0, will be now given as vector NP. We found it as vector R minus D into N cap dot, what is vector ON? Which is D into N cap, which is equal to 0. Let us simplify, find the dot product between these two. So we get vector R dot D into N cap minus D into D square. Next we have N cap dot N cap, which is equal to 0. Vector R dot D into N cap minus D square into N cap dot N cap. What is I cap dot I cap? We know that I cap dot I cap, J cap dot J cap, K cap dot K cap is equal to 1. Therefore, here N cap dot N cap is also equal to 1. In dot product, I dot I, J dot J, K dot K is equal to 1. Hence, N cap dot N cap is also equal to 1. Therefore, D square into 1, it is D square, which is equal to 0. From this, let us take D common. So, if we take D common, we get vector R dot N cap minus D is equal to 0. Now, you should equate it. Now, we should equate D is equal to 0 and R dot N cap minus D is equal to 0. Can distance alone be equal to 0? No. Here also we are told that distance cannot be equal to 0. So here D cannot be equal to 0. Therefore, only which will be equal to 0? Only vector R dot N cap minus D only will be equal to 0, as D cannot be equal to 0. Therefore, we get vector R dot N cap minus D is equal to 0. Why? Because we know that distance cannot be equal to 0. Therefore, from this I can write vector R dot N cap is equal to D. And this is nothing but the equation of the plane in vector form. Let us derive its Cartesian form. So, in order to derive its Cartesian form, so let us write what are the components of vector R first. Cartesian form. So here vector r will be given by what always we write vector r as, we write it as xi cap plus yj cap plus zk. Next, we need to write what n cap is. Here, they have not asked for the vector, they have asked for the unit vector. So, this you should remember, very important. So, here, when I write first, we should know what is vector n. Then we can easily know what is vector n, that is unit vector n cap. Therefore, vector n, we write it as ai cap plus bj cap plus ck cap. Okay, this is vector n. How to write the unit vector? Unit vector will be given by vector n divided by magnitude of vector n, that is n cap. How we write this for vector a, unit vector. Vector a, that is a cap is equal to vector a by magnitude of vector a. Here also n cap will be equal to vector n by magnitude of vector a. So this will be given by ai cap plus bj cap plus ck cap whole divided by root of a square plus b square plus c square. So further, if I simplify this can be written as a divided by root of a square plus b square plus c square into I cap plus b divided by root of a square plus b square plus c square into j cap plus c divided by root of a square plus b square plus c square into k cap. So what is your a by root of a square plus b square plus c square? Can I write this to be as L? Why? Because this is nothing but again the direction cosines. If A, B, C are the direction ratios, then I am already told the direction cosines will be A by root of A square plus B square plus C square. Similarly, M will be equal to B by root of A square plus B square plus C square, and N will be equal to C by root of A square plus B square plus C square. So this is nothing but Li cap M plus Nj cap plus Nk cap. So this is our n cap. Remember, so the vector n will always be written in the form of vector n will always be written in the form of ai cap plus bj cap plus ck cap. Since we need what is unit vector n cap, we know unit vector is given by vector n by magnitude of vector n. So once I simplify this, I get like this. So where a by root of a square plus b square plus c square is nothing but L, which is the direction cosines. So the final n cap will be given by Li cap plus mj cap plus nk. That I am going to write it directly. So in your exams while writing your answers, you can write directly. So n cap is given by Li cap plus mj cap plus nk cap. What are those? Those are the direction cosines for the direction ratios A, B, C. So you can make a note of it while writing your notes. So N, N are direction cosines for the direction ratios A, B, C of the vector N. Okay, for the vector and L, M, N are the direction cosines for the direction ratios A, B, C of the vector and cap. Make a note of all these things that will help you to understand when I solve the problems. Okay, so with this, let us derive what is the Cartesian form of the equation of a plane. So I am going to substitute now the value of vector r and vector n cap in the equation number 1 in vector form. So substituting these values in equation 1. This is equation number 1. So substituting vector r, which is given by xi cap plus yj cap plus zk cap dot vector n cap, that is n cap unit vector, unit normal vector, which is li cap plus mj cap plus nk cap, which is equal to d. Now find the dot product between these two vectors. How to find? We need to just multiply the scalar components of I cap with I cap, then j cap with j cap, and k cap with k cap. So x into n, which can also be written as mx plus my plus mz, which is equal to. This is the Cartesian equation of the plane. That is Lx plus My plus Nz is equal to D is the Cartesian equation of the plane. So here one more thing we should understand. We know we just saw what is the vector equation and Cartesian equation of a plane. So here instead of these two formats, if they can even ask usually in the question they ask in the different format, that is instead of n cap they may even give you as vector n. So let us see that what that is. So just now we saw vector form. So vector r dot n cap is equal to D, and Cartesian form, which is Lx plus My plus Mz is equal to D. So here, if they have given in vector r dot ai cap plus bj cap plus ck cap is equal to p. Now the distance from the origin to the plane I am taking it as p. Why? Because here I have considered vector n, not vector n. That is not unit vector. So when they have considered unit vector, we write it as d. When they have considered only the normal vector, we write it as p. Because always we finally reduce it to this form. Under this condition, this is the vector form, and the Cartesian form will be given as ax plus by plus cz is equal to d, where a, b, c are nothing but the direction ratios of the normal vector n. Direction ratios of the vector n. Okay, so you should be careful in while solving the problems. They always give you in this format. So this is not D, this is P. So while solving the problems, they always give you in this format. That is, they will give you as 2x plus 3y plus 6z. Let us take is equal to 5. If this is an example, then in order to find its vector form or the Cartesian form, we need to reduce it to this form. That is, once they have given the direction ratios, we need to find its direction cosines and reduce it to the form of Lx plus My plus Nz is equal to D. While we solve the problems, that helps you to understand. Let us solve the first question on equation of a plane in normal form. So here they have asked us to determine the direction cosines of the normal to the plane and distance from the origin. Means we need to find D, and also we need to find what is the direction cosines of the normal to the plane. That is for the vector n. So here first and foremost, the given question is given in the form of ax plus by plus cz is equal to p. Okay, we need to find what? We need to find the direction cosines. Means we need to find what is L, M and L. And also I need to find what D is. In order to find that, let us first find what is our direction cosines. So we need to find what is L, M and N. So L we know, which is given by A divided by root of A square plus B square plus C square. Therefore, this is equal to, what is the value of A in this question? It is 2 divided by root of 2 square plus B is 3, therefore 3 square plus C is nothing but minus 1. The coefficient of Z here in the equation is minus 1. So minus 1 the whole square, which is given by 2 divided by root of 2 square 4, 3 square 9, 1 square 1. Therefore 2 divided by root 14. Okay, next. What is the value of m? M will be given by b divided by root of a square plus b square plus c square. So which is equal to, what is the value of b? Which is 3, and we already found what is the value of root of a square plus b square plus c square, which is 3 by root 14. Now can you directly tell me what n is? N is nothing but c by root of a square plus b square plus c square, therefore which is equal to minus 1 by root 14. So we got what is the direction cosines. Therefore the direction cosines are 2 by root 14, comma 3 by root 14 and minus 1 by root 14. After finding the direction cosine, they have also asked us to find what is the distance d. So distance d is nothing but d is equal to what I have given as p, that 5 divided by, in order to find the distance, you should take this 5, this p divided by root of a square plus b square plus c square. So 5 divided by root 14 will be your distance. That is, you should divide the entire equation by root of a square plus b square plus c square, so that you will be able to get what the distance is. Okay, similarly, let us solve the next question. These are the 1 mark questions, students. So you should ready, by looking at this, you should be able to write this step, because you already know what is ABC value. So a by root of a square plus b square plus c square. So 2 by root of, you just calculate 2 square 4, 3 square 9, minus 1 whole square it is 1. Therefore 4 plus 9 plus 1, which is root 14. You need not write all the steps if they have asked for 1. So again, here also we need to find the direction cosines and the distance. So it is in the form of x plus by plus cz is equal to p. Let us find the direction cosines directly. So it should be a by root of x square plus b square plus c square. A value is 1. Root of a square plus b square plus c square. So this is equal to 1 square plus 1 square plus 1 square. Why? Because a value is 1, b value is 1, c value is also 1. Therefore it is nothing but root 3. Next, what is the next? It is b by root of a square plus b square plus c square. So it is 1 by root 3, and similarly c by root of a square plus b square plus c square. It is again 1 by root 3. How to find d? D is nothing but this value, that is the p value 1 divided by root of a square plus b square plus c square, which is root 3 directly. So the next question, so they have given it as 5y is equal to 8. So I write it as minus 5y is equal to 8. You don't write it as 5y is equal to minus 8. When you take it as minus 8, the distance will be negative. The distance cannot be negative. So you should write it as minus 5y is equal to 8. So x is 0. Then we have y given z is 0 plus 0z is equal to 8. Therefore ax plus by plus cz is equal to b. Here the value of a is 0, b is minus 5 and c is 0. Therefore let us find what is the direction cosines. Direction cosines, a by root of a square plus b square plus c square, 0 divided by root of a square plus b square plus c square. Root of a square plus b square plus c square, which is equal to root of a square is 0 square, b square is minus 5 the whole square, c square is 0 square. Therefore, this becomes minus 5 whole square, it is 25. Root 25 is again equal to 5. 0 by 5, comma. Next we have minus 5 by 5. Next it will be 0 by 5, which is equal to, sorry, that's all. Next, if you simplify here, what is 0 by 5 is equal to? 0 by 5 is nothing but 0. Therefore, this is nothing but 0 minus 5 by 5 is minus 1. 0 by 5 is again equal to 0. Next, let us find what is the distance d. D is equal to 8 divided by, what did you get as root of a square plus b square plus c square? We got it as 5. Next problem, here if you see, you have only the z component. So it is understood that the x is 0, means the coefficient of x and y is 0. Therefore, you can write it as 0x plus 0y plus 1z, or z is equal to 2, which is ax in the form of ax plus by plus cz is equal to p. So direction cosines is given by a by, that is 0 by root of 0 square plus 0 square plus 1 square, which is nothing but 1. Next you have 0 by 1. Next you have 1 by 1. Therefore you can write this as 0 comma 0 comma 1. And distance d, which is given by 2 divided by root of a square plus b square plus c square, which is equal to 1. Hence distance d will be equal to 2. Next problem, find the Cartesian equation of the following plane. So they are given in vector form. So they are given in which form? Vector r dot ai cap plus bj cap plus ck cap is equal to p. They are given the Cartesian form. This is vector form. The Cartesian form will be given as ax plus by plus cz is equal to p. You should reduce it this form. So, in order to reduce into this form, first we need to write what vector r is. We know vector r is xi cap plus yj cap plus ck cap dot. Then it is given that I cap plus j cap minus k cap is equal to 2. Find the dot product between these two vectors. So, x into 1, it is 1x. Y into 1, so it is 1y. Then this is z. Z into minus 1, which is minus z, is equal to 2. So this is now reduced into the Cartesian form of the form ax plus by plus cz is equal to p. Now similarly, the next two problems also we can do in the same way. So writing x, which is given by xi cap plus yj cap plus zk cap dot. We have 2i cap plus 3j cap minus 4k cap, which is equal to 1. Therefore, this is given by 2x plus 3y minus 4z is equal to 1. Next problem. So, here also writing vector r, which is xi cap plus yj cap plus zk cap. Dot product with the normal vector, which is s into 2i cap plus 3 minus t into j cap plus 2s plus t is equal to 50. So this will give you what? So we get it as s minus 2 into x plus 3 minus 2 t into y plus 2s plus t into z is equal to 15. So these are so in this way we find the Cartesian equation of the plane. Okay, in this question we need to find what is the vector equation of a plane. So we know what vector equation is. Vector equation is given by vector r dot n cap is equal to d, which is at a distance. So they have given what is the distance. So the next data given is d, which is 6 by root 29 from the origin, and its normal vector. Here, instead of giving a unit vector n cap, they have given the normal vector. So normal vector, which is given by 2i cap minus 3j cap plus 4k cap. These are the data which is given, which we can extract from the question. So in order to find the vector equation, we know what vector r is, what vector what distance d is. We need to find what is the unit vector. So we already know how to find a unit vector. Unit vector is given by vector n divided by magnitude of vector n. And vector n, which is equal to 2i cap minus 3j cap plus 4k cap divided by magnitude, which will be equal to root of 2 square plus minus 3 the whole square plus 4 square. Therefore, this is equal to 2i cap minus 3j cap plus 4k cap divided by root of 2 square 4, 3 square 9, 4 square 16. Therefore, this will be equal to root 29. Therefore, vector n cap will be given by 2 by root 29 into I cap minus 3 by root 29 into j cap plus 4 by root 29 into k cap. Now substitute all these values, that is the value of n cap and d in the vector equation. Hence, vector r dot n cap is equal to d will be given by vector r dot n cap is 2 by root 29 into I cap minus 3 by root 29 into j cap plus 4 by root 29 into k cap, and distance d, which which is given by 6 divided by root 29. This is the vector form of the equation of a line whose distance is 6 by root 29 and the normal vector is 2I cap minus 3j cap plus 4k cap. Next question, you have a similar question. Here, again we need to find what is the vector equation of a plane, and the distance d is given by 7. D is equal to 7 units from the origin to the normal vector, and vector n is given by 3I cap plus 5j cap minus 6k cap. So what we need to find? We need to find what? N cap. So n cap is vector n divided by magnitude of vector n, which is equal to 3I cap plus 5j cap minus 6k cap, whole divided by root of 3 square plus 5 square plus minus 6 the whole square, which is equal to 3I cap plus 5j cap minus 6k cap divided by 3 square 9, 5 square 25, then 6 square 36. Therefore, this will be equal to 36, 45, 45, 50 plus 20. 7, root 7. Therefore, this can be written as 3 by root 70 I cap plus 5 by root 70 j cap minus 6 by root 70 k cap. Therefore, the vector equation is given by vector r dot vector unit vector n cap into d. So, vector r dot n cap, which is 3 by root 70 I cap plus 5 by root 70 j cap minus 6 by root 70 k cap is equal to 7. Okay, students, let us end the class for today till here. In next class, let us take few more problems on equation of a plane in normal form.